happen to you if you bring the daughter home late? Yes. Okay, so this process is known as cleavage, by splitting up the cells, in fact, from zygote to 2-cell, 4-cell, 8-cell, and so on. Okay, and you get a structure that's known as a morula. So it looks like a mulberry, hence the name. Now, we have 4 microscopes set up for you, and since most administrations, government do not allow human cloning as past 8-cell stage anyway, and it's we don't have human zygote for you to study, but what we do have is equivalent cleavage that you see in the starfish or the sea urchin, right? You can see start out similar, develop, fertilizes oocyte. You can see 2-cell stage, 4-cell stage, and it's a very simple exam question. I shows you what a 4-cell stage look like. You just look at it and count how many cells. That's a 4-cell stage, 8-cell stage, morula and blastula, right? So one of your colleagues will set up the microscope and look up to see whether you can see what cell stage that is. In human, usually about day 6 of human development, you get a blastocyst. And a blastocyst this is where you get gastrulation. The term gastrulations means you get invaginations and forming the 3 primitive germ layers, which are your endoderm, mesoderm, and ectoderm. Right? In a lecture, I'm going to talk to you about these. But just to note that a typical blastocyst would look something like this, where you have the outer lines known as trophoblast, and you have this little big thickening regions known as the inner cell mass. The inner cell mass is going to give rise to the embryo. So by usually day 6, the fertilized oocyte will move along down here, and at day 6 is where you get implantation, and it's the blastocysts that get implanted. While the inner cell's mass give rise to the embryo, the trophoblast give rise to what we call ectopic embryonic tissue, which is the major one you can say is give rise to the placenta. Okay? All right. So this will be an exam as well. So one station has to do with this model.